like Damien, I am losing my voice, so hopefully it holds for the rest of the talk. So for the past few days, we've heard a lot about some of the problems that are facing the reef, and we've heard a lot about small-scale solutions. And we've had a lot of sessions of the future large-scale solutions that are coming. And really the link between these two different scales is the deployment of some of the large-scale future solution is likely to use some of the methodology from the small-scale solutions. But also, if you are a local tourism operator or local interest groups, it's the small-scale solutions that will be your toolkit to restore your local reefs. And so, looking at all the diversity of methods, how do you gain an overview of what methods are available to you? Well, you turn to some of the reviews and manuals that Adam's just highlighted in his talk. Some of those, they've been excellent reviews that are available, some of them really seminal ones. But there's been quite a, some of them have been limited in scope geographically, they've been limited by the species they cover, or they would just do an update. And so we set out to do such an update and provide a global, comprehensive review of coral restoration methods. And it was really important to us that the content that went into this review and the output from this review came from not just the scientific literature, but from practitioners and from managers alike. And so, as you can probably guess, that's a pretty mammoth task, and I definitely wasn't alone in this. And this was a real genuine collaboration between a lot of different organizations and people from different institutions. And so when we started looking at what data was available, it became clear that there's a pyramid of knowledge going on here. And we have a giant base of practitioner knowledge. And that is largely unpublished, and some of it just exists in the brains of those people that participated in those projects. Then we have the grey literature, and this is like government reports and that kind of stuff that is available and published, but it hasn't undergone peer review. And then we have the scientific literature. And those three tiers, sort of crudely, also represents the three groups we're trying to include in this project. So we have our practitioners, our managers, and our scientists. And so to gather all this data, we did a traditional lit review. We accessed all of those manuals and reports that Adam mentioned. And then we conducted a large-scale survey of coral restoration practitioners. And if you are a coral restoration practitioner in the room and you haven't filled out our survey, we're still taking entries. And we have our lovely Megan walking around with an iPad, and she will let you fill it in. If you don't have time to grab her, head to the website of our project, gbrcoralrestoration.org, and click your way through to the survey there, because we would really love to hear from everyone here. And we put together all this data into a giant database. We extracted a lot of information from each individual case study, and then we try to make sense of it and see some patterns. And just to give you an overview of some of the data that's in this review, we have 329 case studies from the peer-reviewed literature, the grey literature, and from our survey responses. They represent 52 different countries. All of these were heavily dominated by 4 different countries. We have 10 separate intervention techniques represented in the review, and although 70% of those were transplantation or fragmentation studies of some kind. Overall, the length and size of projects was short and small. If we start by looking at the length of projects, they were 58% were less than 18 months long, and the median length of these projects was about a year. If we look at the size of projects, 3/4 of projects were less than 1,000 square meters in size, with 10% of projects larger than 1 hectare. And the median size of these projects was 440 square meters. If we look at what corals are represented in this review, first looking at morphologies, 80% were some kind of branching morphology, which doesn't seem that diverse. So we were quite surprised when we found that we have 196 species of corals from 77 genera represented in this table, or in this review. And if we zoom in a little bit, we can see that while there's a lot of representation, a quarter of projects, just over a quarter of projects, are on Acropora genus, and more than 1/10 of case studies actually work on the single species Acroporus cervicornis. However, it is encouraging to see that 82% of our case studies in the review have used more than one species in their project. So I wish I could go over all of the interventions that we have in the review, but I don't have time for that. So I'm just going to give you sort of a snapshot of where we have the most amount of data, and that's for our transplantation studies, just to give you an idea of what the kind of data that we've included in this review. And so transplantation studies we've grouped all studies that move corals in one way or another. And there's a few different variations on this. So we have direct transplantation, which is where you move a coral from a donor reef to a recipient reef. We have coral gardening, which is where or asexual propagation, which is where you introduce an intermediate nursery phase. And we have microfragmentation studies where you use tiny, tiny fragments of corals and rear them in intermediate nursery phases. And while there's some variation between these methods, they all have a few stages in common. They all harvest coral to some extent, they then transport them, and they then attach them in one way or another. So I'm going to go into that in a little bit more detail. So when it comes to harvest, the overwhelming majority of studies actually harvest fragments from nearby reefs. I think 46%. I hope you guys can read that because I can't. And 22% of studies actually used a non-destructive harvest method, which is of corals of opportunity, which is where you use coral fragments that are already dislodged from the reef. When it comes to transport, while it seems evident from our data that it's prudent to limit exposure to air and provide shading for your corals, there seems to be species-specific responses. Some corals are really susceptible to exposure to air, and some can stay uncovered for up to 2 hours. So really species-specific responses there. Regardless, when you get your corals to the study site, it seems clear from our data that attachment is better than just scattering your fragments on the reef. And the most common attachment methods were using epoxy, cement or concrete, or cable ties. However, from our data, it's pretty clear that there's no difference in survival between these different attachment methods. So as long as your corals are firmly attached so they can overgrow and self-attach to the substrate, there's no real difference in survival. So this suggests you can pick your attachment method based on what's available at the site. When it comes to outplanting design, we didn't have that much data to look at this in detail, and that's probably why all of our results are species-specific. So looking at the species composition of your outplanting, looking at the orientation of your fragments, and looking at the density of outplanting. Some have strong effects on some species and no effects on other species. And like I said, I wish I could go through all the interventions, but we have this kind of detailed data about methods specific for each of these other intervention types. And instead, I'm just going to spend some time talking about this is early days, but this is some of the major lessons we've learned from going over all this data. And the first is the need for more long-term monitoring of projects using a wider variety of indicators. And this is not new. This was highlighted by an excellent review by Margot Hein last year. I've heard it's available on ResearchGate if you don't have access to it. And she outlines 10 different indicators of success that you should measure on coral restoration projects. And she's also talking next, so stick around for that. But this was really highlighted in our review as well, where 69% of all of our case studies only measured something biological. So that's growth and survival of your corals. And even more surprising was that of the 116 studies that actually explicitly stated an ecological outcome as an objective, less than 50% measured something relating to that objective. So that's really something to keep in mind and broaden the monitoring of projects and evaluating the success of projects. The second is the need for standardization in studies. If we are to compare the success of different methods to each other, we need to be using the same metrics. And so just some examples. If we are comparing the numbers of corals that have been outplanted, are we comparing small fragments, or are we comparing full, complete coral colonies? When we're comparing survival of our studies, are we talking about partial survival, or are we talking about the complete survival of your outplant? When we're talking about projects that are multiple stages, what is the ultimate survival of our corals in those projects? If you have 62% survival in your nurseries, and then you have 59% survival in your outplants, is that really 59% survival, or is that 59 of 62 that survived in your nurseries? So you're actually talking about a 37% survival. I'm not saying I think that that's how it is, I'm just saying that it's something we need to think about when we're reporting the success of restoration projects. Another thing that's become really clear is the need to consider the environmental impact of your restoration project. It's kind of ironic that in some cases the materials and methods we're using to mitigate issues on coral reefs are directly contributing to those issues on those reefs. So for example, one of the most common materials used is concrete and cement, which has a huge carbon footprint. Wikipedia told me last night that 5% of the global carbon emissions comes from the production of concrete. And so I really think it's something that we should consider thinking about when we're planning our projects, that we're not actually contributing directly to the problem we're trying to mitigate. Similarly, plastics are a really common tool in coral restoration. We use cable ties, we use PVC pipes, we use fishing line, and those all break down into microplastics and contribute to that growing problem in our oceans. And while I don't know of an environmentally friendly version of concrete, there are so-called biodegradable cable ties and biodegradable fishing line available, and I would really urge practitioners to consider the impact of their projects going forward. And one more point I have to make is that I haven't mentioned the economics of, or the cost of different restoration projects, because Phoebe Stewart-Sinclair will be covering that in 2 talks' time, so stick around for that. And I am almost running out of time, but I also want to talk about some of the outputs from our project. And so this online database, once it's finalized, we will make that available to anyone to have a look at and peruse if you really want to nerd out and look at our massive data set, except for the survey results because they're anonymous. But we have also started making an interactive online database that basically visualizes this and allows you to click through and filter all the data and leads you to references. So this is an early draft of this. Yes, it works. Okay, so it will be a lot prettier and have a lot more functionality. Something going on there. I just clicked on coral gardening, so it now shows me all the studies that deal with coral gardening. And now I'm clicking on those that have used transplantation of fragments. Then I'm clicking on the ones that attach their fragments with cable ties. And then I scroll down and I get to the references that back that information up. I click on it and it will take me straight to the source, in this case a report on the Gubrumpa website. And so this is going to have a lot more functionality, and we're building and working on that, and we have been talking about maybe hosting it on the Reef Resilience Network website. And so we're really excited about this, and we're happy to hear your thoughts about how we can, what shape this could take to be useful to you guys. And I think that's it. That's all I have time for, but I'm happy to chat further and take any questions. And if you haven't filled out our survey, grab Megan or go to our website.